Of course, since the derivative of e to the x is e to the x, the integral of e to the x is again e to the x. However, if it's e power by a function, needs to be the e power by the function d, the function, the integral to be e to the u. So let's see how it works. For example, 91. e to the 5x times 5 dx is the same thing as integral of e to the 5x d 5 times x, and that's e to the u du, so the result is going to be e to the u, e to the 5x plus a constant. For question 94, it's integral e to the 1 minus 3x dx. Well, we can always multiply with negative 3 the x as long as we divide by negative 3. And then we can always plus a 1 because derivative of 1 is 0. So again we have e to the u du, which the result is going to be negative 1/3 e to the u. Now for question 95, we have integral of x squared times ex cubed dx. We can think about this problem in two different ways. First of all, we can say, well, let's partially integrate just x squared. So since integral of x squared dx is equal to x to the 3rd over 3 dx, 3rd over 3 plus c, that's the same thing as going, well, that's derivative of x to the 3rd, 1/3 1/3. So this part here is equal to that, and now we have e to the u du, or that's 1/3 ex cubed plus c. If you don't feel comfortable with this, you can solve it by using your substitution. I'm going to put that note here, that's going to be some note to be related to this equal sign. Okay, so that's method 1, let's say, method 1. And with method 2, we can say, well, let u be equal to x cubed, then du is going to be 3x squared dx, or x squared dx is 1/3 du. So by using this substitution here, this problem become 1/3 integral of e to the u du, and that's 1/3 e to the u plus c, which again we need to go back to x, so that's 1/3 e to the x cubed plus c. In exercise, find the indefinite integral, so the same set of exercise continues. Question 99. We can say, well, let u be equal to 1 plus e power by negative x. Then du is going to be negative e to the negative x dx. Or since in this problem I only need e to the negative x dx, I'm going to give the negative sign to the du. Well, based on this u substitution, we have integral e to the negative x dx become the negative du, so that's negative du divided by u, or the result is negative ln of u plus a constant. Go back to x, that's negative ln of 1 plus e to the negative x plus a constant. Continue with some more examples. 106. For 106, notice that, and we've been talking about this before, a plus b divided by c is good. Because we can always distribute the c and simplify the expression. It's a problem when it's a over b plus c, because we cannot do a divided by b plus a divided by c, so that's bad. So every time when you have every time when you have an opportunity to simplify, you're gonna simplify. So this integral here is gonna look like integral e to the 2x divided by e to the x plus 2 e to the x divided by e to the x plus 1 over e to the x dx. And of course that can be simplified to that's e to the 2x minus x, which is just x. Here we have cancel those, that's just a plus 2, and the last one would be e power by negative x dx. So let's rewrite it finally. E to the x plus 2 plus e to the negative x dx. And now let us integrate. Integral of e to the x is e to the x, integral of 2 is 2x, and integral of e to the negative x is e to the negative x times the derivative of negative x, which is negative 1. Plus a constant, or finally e to the x plus 2x minus e to the negative x plus a constant. More examples. 114. Now those examples, that's a definite integral, so make sure that you change the variables or you use indefinite integrals to solve the problem. So if I'm gonna use indefinite integrals, let's diverse a little bit. So if I'm gonna use indefinite integral, I'm gonna solve integral x e to the negative x squared over 2 dx. So make sure that you don't put any boundaries. Use your substitution. Let u be equal to e to the negative x squared over 2. Derivative du is going to be e to the same thing times the derivative of the exponent, and the derivative of the exponent is negative 1/2 times derivative of x squared is 2x dx, or du is negative x e to the negative x squared over 2 dx. Now since in this problem I don't have a negative, I should give the negative to the du. So x times e power by negative x squared over 2 dx is equal to negative du. So go back in the problem. I would say, well, that's my du here. That whole thing here is my du. That's the du. So this integral is equal to negative du, or that's equal to negative u plus a constant, or negative e to the negative x squared over 2 plus a constant. Now, so once I'm done with that, I'll go, okay, from here, integral from 0 to square root of 2 x e to the negative x squared over 2 dx is equal to what that's equal. That's negative e to the negative x squared over 2 to be evaluated between 0 and square root of 2. We'll plug in. That's negative e to the negative square root of 2 squared over 2 minus negative e power by negative 0 squared over 2. Now square root of 2 squared is 2, so 2 and 2 cancel out. We have negative e power by negative 1 minus e to the 0, or negative 1 over e. E to the 0 is 1, this is 1, so plus 1. So this was if we solve indefinite integrals first. Let's do different approach for question 117. That's integral between 0 and pi over 2 of e to the sine pi x of cosine pi x dx. I forgot to mention for the previous example, I did take e to be the entire e to the negative x squared over 2. Some may have wanted the u to be just the x squared over 2. That's fine, you are gonna receive the same result. So here, let's apply u substitution by changing the limits. We have, let's u be equal to e sine pi x. Then du is going to be the same thing times the derivative of sine pi x, which is cosine pi x, times the derivative of pi x, which is pi dx. Now, to be able to solve for e sine pi x times cosine pi x only, I need to divide by pi both sides, so that's 1 over pi du. What else we want to know is, we want to know when x is equal to 0, what is u? And u is going to be e power by sine of 0, and sine of 0 is 0, so e to the 0, or 1. And when x is equal to pi over 2, then u is e power by sine of pi over 2 times pi, which is e power by sine of pi squared over 2. With all this set, we can solve the problem. So this whole thing right here is given by 1 over pi du. So that's integral of 1 over pi du. The limit at 0 is going to be, u is going to be starting from 1. And then instead of going to pi over 2, we're going to be going to e power by sine of pi squared over 2. So e power by sine of pi squared over 2. So that's my upper boundary. Alright, so the answer is 1 over pi u to be evaluated between 1 and e power by sine pi squared over 2. Well, my final answer is going to be 1 over pi u being e sine of pi squared over 2 minus 1. So that's my final answer. Now, this is a great example to show you, so if that's my method 1 here, to give an example for how faster to solve this problem. Again, it was from 0 to pi over 2 e sine of pi x cosine pi x dx. So we can think, okay, this whole thing here is equal to d sine of pi x, provided that I multiply with pi and divide by pi this expression. So that's equal to 1 over pi integral between 0 and pi over 2 e power by sine pi x d sine pi x. And you can check by differentiation that derivative of sine pi x is in fact pi times cosine pi x dx. Now I have integral of e to the u du. So my answer is going to be e to the u sine pi x, where x changes between 0 and pi over 2. And of course, by substituting back, I'll have e power by sine pi times x, which is pi over 2, so pi squared over 2, minus e sine to the 0. And my final answer is 1 over pi e sine pi squared over 2 minus sine of 0 is 0 and e to the 0 is 1. So I'm getting the same answer.